Alright guys, I hope you guys are doing good. So this is section 3.9 from the book, okay? And this section we'll talk about a linear approximation and differentials, okay? So first of all, linear approximation, why do we need this? So sometimes your function fx looks like very complicated, and if you want to find the height of the function, this is the function fx, right? If you want to find the height of the function at c and around c, for example, I want to find the height of the function at this point, which is close to c but on the right side. Similarly, I want to find the height of the function at this point, which is close to c but on the left side, right? So how do I find out the height? Because this function is so complicated, the equation may be complicated, so it may be harder to find out by plugging in that point to the x in the function, right? What we do instead is we find out the equation of the tangent line, okay, at the point c, and then find the height of the tangent line instead of the height of the function, which is suppose that is complicated form. What we do is we find the height of the tangent line near c. That height will not be that different. It depends on the function. So if you want to find out the height of the function very close to c, let's say here, or very close to c on the left side, let's say there, then that height can be well approximated by the height of the tangent line, right? So that's how it works. So what we do here is, so let's find out, so this is c, so what is the coordinate of this point? This point will be, basically, let me write down that this point will be, this point basically is c and then fc, right? So I want to find out the equation of the tangent at c comma fc. So it is like x1 y1, right? So what is the equation of the tangent line? It is like y minus y1 equals to f prime or m, you can say m, and then x minus x1, right? So f prime at x1. That's the equation of the tangent line. So f prime is the slope m. So y minus y1 equals to m, x minus x1. You guys know this. Now, so if you plug in that x1 is c and then y1 is fc, you'll get y minus fc equals to f prime of c is the slope and then x minus c. And if you solve for y, you'll get y equals to, you add fc on both sides, right? So if you add fc on both sides, this is what you get, y equals to fc plus f prime of c times x minus c. This is what you get. So we denote this by tx because this is the equation of the tangent line, right? So y is basically fx, function of x, but here what we write is tx, just to note that this is the equation of the tangent line, okay? The value of c will be given to you, that is x equals to c, right? And you just plug in the values there. Okay, let's see one example. Use tangent line approximation for fx equals to root x. This is the function, fx equals to root x at x equals to 4. So this 4 is basically the c, right? Also approximate the value of fx at x equals 3.9, 4.01, 4.1, and so on. So what it is saying is, maybe if you are asked to find out what is the value of fx, this is the fx, when x equals to 4. At x equals to 4, it is 2, right? Because root 4, that is 2. But it is hard to find out at 3.9. If you plug in 3.9, then you cannot do it directly. You'll have to use calculator for this. And at x equals to 4.01, also it is hard. At x equals to 4.1, it is not straightforward. So how do we do that is, we'll find out equation of the tangent line at x equals to 4, and then use that tangent line to find out the value at x equals 3.9, 4.01, 4.1, and so on, okay? That is that equation to find out that, okay guys? Okay, all right. So calculate these values using calculator too. So this is the using calculator. So this is using calculator. This is using the tangent line, okay? So let's find out first find out f prime x. So what we have is fx is root under x, right? So how do I find out the tangent line? This is basically x to the 1/2. So to find out the derivative, it is like 1/2 and then x to the 1/2 x to the 1/2 minus 1, that is negative 1/2, right? So if you simplify this, it will be 1/2 root under x. This is the derivative, right? Now we need to find out the equation of tangent line. To find out the equation of tangent line, what is c? X equals to c is 4. So it is y equals to f at c. F at c is 4, right? So it will be like f at 4 is root under 4, right? Root under 4 plus f prime at 4. What is f prime at 4? F prime at 4 is 1/2 root under 4, right? 1/2 root under 4. That's what you get. And then times x is, just keep x and then minus 4. So if you simplify this, you will get tx equals to you will get, so you'll get tx equals to root 4 plus 2 1/2 root 4 and then times x minus 4. So this will be like 2, right? And then plus, what is, how much is that? 1/2 times 2, right? 1/4 times x minus 4, right? If you simplify this, how do I simplify it? It will be like 2 plus 1/4 x minus 1/4 times 4 is 1, right? So that will be 2 minus 1. So it will be basically tx equals to, you get a 1/4 x plus 1, right? Because there is 2 and then 1/4 times negative 4 will be negative 1. So 2 minus 1 will be 1/4 x plus 1. Now, so let's plug in this value of x, 3.9, 4.01, 4.1 at fx. Fx is that, you use calculator to find out that. And then at tx, you can use calculator, but you need to use this equation to find out tx, okay? You will see that those two values are almost the same. Why? Because we are using the tangent line to approximate the height of this function. So close to that point, close to the tangent, that the point where we found the tangent, the height of the tangent and the height of the function are almost the same. That's what we call linear approximation, because we draw a tangent line at C and then we use tangent line to find out the height of the function, okay? So when 3.9, okay, now we use this function, the given function fx equals to root x and the tangent line, and then check if you get the similar values near x equals to 4. Similar value means the value of the function using calculator and value of the tangent line, or you can say height of the function and height of the tangent line close to the point x equals to 4. I took 3 points, 3.9, 4.01 and 4.1. I want to see whether these two values are equal or not. Basically, they should be almost equal. They should be close. Okay. So what I did, I used calculator for fx equals to root x, and then I use root under 3.9, root under 4.01, root under 4.1, and I found these values. And then the tx is basically this equation. I use this equation. Okay, I take x equals to 3.9, I got 1.975. You see that they are almost the same. And when I take x equals to 4.01, I got 2.0025. Similarly, at x equals to 4.1, I got 2.025. Basically, these values are almost the equal. So you can say that you can approximate the value of a function by drawing a tangent line at a point, and you can approximate the value of the function around that point. Okay. All right. So the next thing is differential. So we know that, look at this. This is a function fx. Okay, this graph is the function fx, and there is a point c. So the point on the graph is c comma fc, right? C comma fc is the y value, right? So what is the equation of the tangent line there? It is y minus y1 is fc equals to m is the slope, right? F prime of c times x minus c. So that's the equation of this tangent line I draw. That is the equation of that tangent line. Now, what I want to do is, I want to pick another point close to C. Okay, that point is C plus delta x. Why did I pick delta x? It's a very small number. since it is added to the x coordinate, that's why I said c plus delta x. That's how I denote, okay? So that c plus delta x can be on the left side, that delta x will be negative sign at that time, okay? Or you can write c minus delta x here, but it's the same thing. So at c plus delta x, at the point close to c, that is the point on the curve, right? So the curve is c plus delta x, that is the x coordinate, and the y coordinate is f at c plus delta x, right? That is the point on the curve. Now I want to know how much is the height of the function at c plus delta x. To do that, what you do is you find the equation of tangent. You found the equation of tangent line already. That's the equation of the tangent line, right? And then plug in that x and then y. So this is like x on the tangent line, this is like y on the tangent line. What you get is you replace y by f of c plus delta x minus fc as it is, and equals to f prime of c is there. So x is basically c plus delta x, right? C plus delta x minus c. Now there is positive c and negative c, you cancel out. And then on the left you got this f c plus delta x minus fc equals to f prime of c times this is delta x, right? Although there is plus, you have this is parentheses, so that's times delta x. Now you denote that quantity by delta x. If you denote that quantity by delta x, then you can write that delta y equals to f prime of c times delta x, okay? So if delta x is small enough, meaning if that point is close to c, then the delta x is very small. In that case, we denote the delta x by dx. And similarly, we denote the delta y by dy, okay? We say the limiting condition, limiting position, meaning when the delta x is close to 0, very small, close to 0. At that time, we denote the delta x by dx, and then delta y by dy, okay? So this becomes dy equals to f prime of c times the dx. This is called differential, okay? So in the homework problem, there are two things that you will be asked. One is find the differential dy. How do I find the differential dy? At a point is you do f prime at c. C will be given like x equals to 2, x equals to 4, like that. So the f prime of c, f prime at c times the dx. So dx you will take same as the delta x, so not a problem, okay? So, and then sometimes they ask you to find out the difference, that is delta y. What is the value of delta y? Delta y is f c plus delta x minus fc. That's how you find out delta y. Or in general form, instead of c, you can write x, and then whatever x value is given, you will plug in there, right? So dy is f prime of x times dx, and delta y is f of x plus delta x minus f of x. So these are the two things you will be asked to find out in the homework problem. Okay, let's take one example. So find dy and delta y from y equals to x to the 4 plus 6 at x equals to -1, and delta x is given 0.01. So this delta x is basically same as dx, right? So how do I do that is to find out dy, we need f prime of x times dx. So you need to find out the derivative, right? So solution is here. You have f of x is equals to x to the 4 plus 6, right? That's the given y or fx. So what is f prime of x? F prime of x is, can you find the derivative of this? This is like 4x cubed, right? 4x to the third. So to find out the dy, you need to find out f prime of x at c, right? So what is f prime at -1 then? F prime of -1 will be basically 4 times -1 to the cube, right? -1 to the cube. So this will be -4. You understand that? So therefore dy is given as f prime at c times dx, right? So you got f prime at c is -1 here, so f prime of -1 is -4 times the dx is 0.01, right? This is times. So if you plug in the value, you'll get negative 0.04. This is dy. Let's find out delta y. What is the formula to find out delta y? Delta y is basically f of c plus delta x minus f at c, right? So what is a c? C is f, let's do f. C is basically -1 plus delta x is 0.01 and then minus f at -1, right? So how much is that? This will be f at -1 plus 0.01 will be negative 0.99 and then minus f at -1, f at -1. So what is f at -0.99? You plug in here, right? Because you plug in here or here. So x is negative 0.99. That will be basically, let me write down here. This will be negative 0.99 to the 4 plus 6 and then minus f at -1 will be -1 to the 4 plus 6, right? You do the same thing, just plug in -1. So if you simplify this, or you can use calculator for that, you get negative 0.0394, negative 0.0394. You see that you got almost the same value, negative 0.04. This is for dy, and for delta y you got almost negative 0.04 if you round up, right? So you got almost the same values for dy and delta y for this problem. Okay, thank you guys.